Hello, this is the first video for Chapter 5, which discusses loops. This particular video will go over the concepts of a loop and the particular syntax of while and do-while loops, giving a hands-on example to show you these concepts in practice. A loop is a structure that allows repeated execution of a block of statements. It executes a Boolean expression to determine whether to continue to execute the loop or to exit the loop. A loop is similar to an if statement in that at the beginning, or sometimes at the end, as we'll see, a Boolean expression, which can be a comparison statement or a Boolean variable, something that can be evaluated as true or false, is examined. And if the Boolean expression is true, then the programming statements inside of the structure are executed. The difference is that in an if statement, everything is only executed once. In a loop, the set of instructions inside of the loop or the loop body continues to be executed over and over and over again until that Boolean expression is no longer true. Each time it goes through, the looping structure or the loop body is called an iteration. So here's how you would include a loop in a flowchart. You can see that you evaluate a Boolean expression, and if it's true, you execute the loop body, and then you evaluate the Boolean expression again. If it's still true, you do the loop body again. Then you evaluate the Boolean expression again. You keep going around and around until the Boolean expression is evaluated as false. So the most basic type of loop is a while loop, and it's used to execute a body of statements continuously as long as some condition continues to be true. So the syntax of a while loop consists of the keyword while, a Boolean expression within parentheses, and then the loop body. Now, in order for a while statement to work, you have to create a loop control variable and somewhere in your code before your while loop starts, somewhere before the while keyword. And then that loop control variable is tested in the while expression, and the body of the loop alters the value of that control variable so that you eventually exit the loop. If you didn't ever alter the value of that variable, then the loop would continuously go forever, and it would be what we call an infinite loop. So here is an example of the syntax from the textbook. Again, it's just the while keyword, and then within the parentheses, something that can be evaluated as true or false, and that should include the control variable. So in this case, the control variable, which was defined above, was this integer variable called number. It was assigned an initial value of 1 when the variable was initialized. So at this point in the code, if 1 is less than this limit variable, which in this case is 5, then the code inside these braces is going to be executed. So number is less than 5, so the program writes hello to the console and then increases the value of number by 1. So now number is 2. And then it goes back to the beginning and evaluates, is number less than limit? Is 2 less than 5? Yes. Then I'm going to write hello again, and I'm going to add another number, or excuse me, add 1 to the variable number. So now number is assigned the value of 3. We go back to the beginning. Is number less than limit? Is yes, 3 is less than 5. So we go through the loop again. We write hello a third time, and then we increment by 1. Now number has a value of 4. Is 4 less than 5? Yes. So we write hello one more time, and then number becomes 5. Then we loop around. Is 5 less than 5? No. So then we can finally exit the loop statement, or exit the loop. Always put curly braces around the body of your loop. And just like an if statement, don't put a semicolon after the control statement. All right, let me jump over and let's do a new Visual Studio application. I'm going to call it Bank Interest. And this application is going to add interest to the amount of money that you have in your bank account. So this is something that happens on a regular basis, something that happens over and over and over again. So the calculation to add interest to your balance is something that we can repeat multiple times in a loop. So first I'm going to add a text box to my form. And this text box I'm going to rename as initial balance text box. And I'm going to put a label there instructing the user to input your initial balance. Okay, then I'm also going to put another text box I'll call it the num periods text box. So how many time periods we're going to add interest to the initial balance. So I'll add a label instructing the user how many time periods. Then I will put a button which will say calculate, and I will rename it to be called the calculate button. And finally, a label to put the result. So I'm going to call this label result label. And have it include the default text. Interest accrued. Okay, I'm going to double click on my calculate button to generate a calculate button click event method. Now I want to accept the initial balance as a double, so I'm going to initialize a variable called double balance, and its starting value will be the input from the user converted to a double. Okay, we'll have an integer for number of periods. This could be years, could be months, whatever time period we're assuming that interest gets accrued. So we'll convert to an integer the what did I call that? Number of periods text box dot text. Okay, so if we were just going, well, initialize tax rate. So let's have this as a constant. Let's say it's 5%. Whoops, I need to give that a name. Okay. Now, before we jump in and do the loop, let's just think about if we were to add interest to our balance one time, how would we do that? So interest would be an amount that has a decimal, so we'll save it as a double. That would be calculated as the balance times the, oh, I didn't want to call this, sorry, it's late. This isn't a tax problem, it's an interest problem. Your balance times your interest rate will be the amount of interest that you accrue. Okay, and then display interest earned to the user. So there in my result label text property, I would assign the interest. Let's concatenate that with the string interest earned. Did I say earned or accrued on the, oh, I said accrued. Interest accrued. And then concatenate that with the interest converted to a string in, whoops, currency format. Okay, so this would be if we were ignoring the number of periods and we just wanted to calculate one period of interest accrued. Now, if we want to do interest for as many periods as the user specified, then we will put this calculation inside of a loop. So I'm actually going to separate, instead of having this be an initialization, I'm just going to be, well, I'm gonna declare this interest variable and set a default value of 0. And I'm actually going to move that line of code up here. So these two lines initialize interest rate and set initial interest value to 0. Okay. And then down here, our interest will be our current balance times the interest rate. Okay, and we'll also want to update our balance. So our balance is our previous balance plus the interest that we have accrued. Okay. So if I want to do this not for just one period, but for however many periods the user input, then I can put these calculations inside of a loop. So the one I will show you right now is the while loop. So while, and then we need to have some control statement, and then the loop body will consist of calculating the interest and updating the balance as many times as we need to loop through this. Okay, so we need to create a loop control variable. So I'll just call it count, and we will start it at 0. And then we can say, while count is less than the number of periods that the user specified, then we will do this calculation. Okay, so let's think about conceptually what happens as the computer runs through this code. First, it collects the inputs, then we establish the interest values, and then we create our loop control variable. Now when we get to here, the computer is going to evaluate, okay, is count less than the number of periods? Is 0 less than, let's say the user put 3 periods. We're going to calculate interest over 3 time periods. So is 0 less than 3? Yes. So we're going to calculate the interest on our initial balance, and then we're going to add that interest, and then we're going to update our balance. So let's say our initial balance was $100. The interest would be calculated as $5, and the balance is updated now to $105. Then when we reach the end of the loop, we start over. We go back and we evaluate. Is count still less than number of periods? Well, yes, because count is still 0. This, as I have it right now, is an infinite loop because it's always evaluating if count is less than the number of periods, and that's never going to change unless I do something inside of my loop to change it. So what you do at the end of a while loop, the last thing is to increment your control variable or your count variable. Okay. So here, the first time through the loop, count is equal to 0. Now count is equal to 1. So then we go back and reevaluate. 1 is less than 3, so we do it again. The interest is calculated, $105 times the interest rate ends up being, 110 point something or 111 point something, I don't know. And so then we calculate that, we update the balance, increase the count variable to be 2. Now we start over. Is 2 less than 3? Yes. So we execute this code again. Keep going. And now we update the count variable so that it is 3. Is 3 less than 3? No. So we're done. So we have calculated the interest 3 times. All right, now I'm going to test it. Say my initial balance is 100. Time period was just 1. I have earned $5. Okay, if I start with 100 and I do 2 time periods, my interest 525. That doesn't seem right. Looks like I might have messed up somewhere. Okay, so I think I know what happened. So what it's actually doing, it's not calculating the total amount of interest we've accrued. It's just telling us the amount of interest that we accrue on that time period. So if I put 103 time periods on the third time period, the amount of interest that I accrue that third time is $5.51. It's not the total amount of interest that we have accrued. So if I want to change my code so that I keep a running tally of the total amount of interest that I've earned, then I'll need to create yet another variable. So this interest variable represents the interest that I earn in any single given time period. If I want to keep track of the total interest earned, then I'll need to create a separate variable for that. So then what I would want to do is every time I go through the loop, I'll calculate the interest for that particular time period. I will add it to my balance, and I will also add it to my total interest. So every time I go through the loop, every time I go through a time period, if this is interest accruing monthly, then every time we get to the end of a month, we calculate the interest for that month. We update the balance. We add the interest for that month to our total amount of interest. And then we increment our account variable. So down here, I actually want to display, instead of the interest for that single time period, I want to display the total interest in my string. Test that out now. So initial balance is 100 if I have 2 time periods. Yeah, that looks better. And I will have earned $10.25 in interest over those time periods. Yeah, cool. All right, so a couple of things to point out here. I've just demonstrated an example of a definite loop or a counted loop. So the number, well, actually, no, I just demonstrated an indefinite loop. Not an infinite loop, but an indefinite loop. So the value of the loop control variable was determined by the user input. The user said 3 time periods or 2 time periods, and that is what controlled the loop. Now, if you just hard-coded in a number for your control variable, so while count is less than 5, you put a specific number in there, that's a definite loop. An indefinite one is one that is controlled by user input. Now, a sentinel value loop is, we don't see these so much anymore. They were very useful in text-based applications. With GUIs, you don't really need them. But sentinel values were used when you wanted a computer program to keep running until a user hit, like, yes, I would like to exit, or input a no for no, I would not like to continue. And the textbook gives an example of that. So here's the code, and you can pause and examine this code more carefully if you like. But it shows how you would create a program where it asks for your balance, yes or no, and then it keeps asking you if you want to see next year's balance, and it keeps going and going until you input no. With GUI-based applications, we don't really have a need for sentinel value loops that much anymore, because if the user is able to move the mouse around and click on stuff, then they can just repeat the action as many times as they want to click with the mouse. They don't have to make the computer keep running the application until they finally type an N for no into the text-based application. Okay. Another type of loop is the do statement, which is also called the do while. It's very similar to the while loop, except that it checks the Boolean statement at the bottom of the loop instead of at the top. So you don't really use this as much in practice, but you might stumble across some application somewhere where you'll want to use a do loop. So a do loop you would use when you know that you want, no matter what, you want the code inside of the loop to execute at least once. And then when you get to the end of the statement, it checks the Boolean statement to see whether it's true or false. If it's true, it continues for a second time and as many times until the Boolean expression is evaluated as false. So the do loop is a post-test loop, and the while loop, as well as the for loop, which we'll go over in the next video, are pre-test loops. Those are ones where the control variable is tested in a Boolean expression before the loop body executes. So these flowcharts show the difference between a while and a do statement. Well, the flowchart doesn't show the difference, but if you compare this flowchart to the flowchart at the beginning of this video, you can see the difference. So the example that the textbook gives is, again, that sentinel value of doing something at least once, and then you ask the user if they want it to repeat. The syntax for the do statement is simply to start it with the word do, and then your curly brace starts, and you put all of the instructions, the loop body, and the brace inside the braces, and then at the end you put your while keyword with your Boolean expression inside the parentheses. So it's basically the same as a while loop, except the keyword while and the Boolean expression you move to the end, and then at the beginning you just stick the keyword do.